Rockwell International's new double-disc pull-type clutch has been designed to provide you with thousands of trouble-free miles under the most demanding on- and off-highway conditions. Because today's high-torque, low-RPM engines impose extra loads on the vehicle's drivetrain, installation and adjustment of the clutch are very important. This training program is presented in 3 parts. First, we'll look at the features of the Rockwell double-disc pull-type clutch. Then we'll discuss how to install it properly, followed by the procedures for proper adjustment of the clutch. One of the real pluses that this clutch offers is that it's a product of Rockwell International. And in the heavy-duty trucking industry, that means an innovative design, well-engineered, quality built, and backed by the best service in the industry. We're producing models of our double-disc clutch to fit U.S. engine and transmission combinations in Class 6, 7, and 8 vehicles with no modifications required. To meet the various requirements, we have a 14-inch and a 15.5-inch clutch in a 2-plate design. We use both cerametallic and a patented molded non-asbestos organic lining on the discs so that the right type of lining can be used to meet specific driving requirements. You'll notice that, unlike other manufacturers, we do not use rivets to fasten the organic clutch linings. Instead, our linings are fastened to the disc by a molding process during manufacture. With our patented molding process, more lining is available for service, and that means substantially longer disc life. Another design feature is the pattern on top of this organic lining. It helps to dissipate heat to prevent clutch bursting, which occurs when the linings become too hot and separate from the discs. Also, between the disc and the hub, there are 2 friction washers and 2 Belleville springs. We use them to help reduce driveline vibration. The Rockwell pull-type clutch uses a dampened disc assembly with coaxial springs for quieter operation and to protect the powertrain system, particularly the splines of the transmission input shaft. To help keep the clutch cool, we've provided 3 large windows in the cover for maximum ventilation. 4 straps fasten the clutch cover to the pressure plate. The straps reduce vibration and assist in moving the pressure plate when the clutch is released. The release bearing is available with either a greasable fitting or with a lubed-for-life sealed assembly. Our diaphragm spring design requires less pedal effort to release the clutch. The result, easier modulation and improved driver comfort. The benefits of these design features are smoother operation on the road, longer lining life, a reduction in maintenance, and the proven reliability of Rockwell products. Now, let's learn how to remove, install, and adjust the Rockwell double-disc clutch to assure proper operation and long life. The vehicle's transmission is disconnected and removed by following the specific manufacturer's procedures. It's a good idea to mark the drive shaft, output yoke of the transmission, air lines, electrical connections, and clutch linkage to aid in proper reconnection. On non-synchronized transmissions, you'll have to remove the clutch brake from the input shaft of the transmission. The first step in the removal of the old clutch is the installation of a spline alignment tool in the pilot bearing of the flywheel for support of the assembly. The tool splines must match the splines in the clutch discs. The tool in the proper size is available from either Owatonna Tool Company or Kentmore Tools. A transmission input shaft can be converted into a tool. If you use this technique, make sure the splines of the shaft are not damaged. After removing the top 2 bolts that fasten the pressure plate and clutch cover assembly to the flywheel, guide studs are installed in the holes. The guide studs are 3/8 bolts with the heads ground off. Blocks are positioned between the release bearing assembly and the clutch cover to release the pressure of the springs when the clutch is removed. When the remaining bolts that fasten the assembly to the flywheel are removed, The clutch cover can be lifted over the alignment tool and off the flywheel. The 14-inch clutch cover can be lifted by hand. However, the 15.5-inch clutch cover should be removed by a lifting device. The alignment tool can now be withdrawn. Then the rear-driven disc is removed, followed by the anti-rattle clips. Then the center plate, and the front-driven disc. The guide studs are also removed at this time. Rockwell recommends that each time the clutch assembly is serviced or the engine removed, the pilot bearing in the flywheel should also be removed and replaced. The old pilot bearing is discarded. Rockwell clutches do not use asbestos in the clutch lining. However, if you find asbestos deposits from the old clutch linings, they should be removed by vacuuming. Prior to installing the new clutch, the flywheel must be inspected for wear or damage. Minor wear, heat checks, or damage of the flat surface can be removed by grinding, as specified by the manufacturer of the engine. Damaged or worn teeth on the outer surface of the flywheel, excessive wear on the flat surface, and heat checks that cannot be removed will require replacement of the flywheel. A more complete inspection, including checking runout and end play, must also be performed when changing the clutch. Use a dial indicator to check runout of the following: the outer edge of the flywheel, the bore of the pilot bearing, the outer surface of the flywheel housing, and the bore of the flywheel housing. The end play of the crankshaft is also checked with the dial indicator. To check the runout of the outer edge of the flywheel face, and for all runout measurements, you must push the flywheel toward the engine. This prevents crankshaft end play from affecting the dial indicator readings. Install the dial indicator so that the base is on the mounting surface of the flywheel housing and the tip is against the outer edge of the flywheel face. Put the dial indicator on 0 and manually turn the crankshaft 1 full revolution in the direction of engine rotation. The maximum runout allowed for the outer edge of the flywheel is 7/1000ths of an inch for 14-inch clutches and 8/1000ths for 15.5-inch clutches. If the maximum runout is exceeded, the flywheel should be serviced according to the recommended procedure of the engine manufacturer. To check the runout of the bore of the pilot bearing, keep the base of the dial indicator in place, but put the tip against the bore of the pilot bearing. Rotate the crankshaft 1 full revolution in the direction of engine rotation and read the indicator. If the reading exceeds the specified 5/1000ths of an inch, review the engine manufacturer's recommended service procedure. A dial indicator is installed to check the runout on the outer surface of the flywheel housing. The base is placed on the flywheel. The tip is placed against the mounting surface of the flywheel housing. Maximum runout for the mounting surface of the flywheel housing is 8/1000ths of an inch. The runout reading should be recorded. If runout is over 8/1000ths, service the flywheel housing according to the vehicle manufacturer's procedures. To check the runout in the bore of the flywheel housing, the base of the dial indicator must be over the center of the flywheel and the tip against the inner bore. Again, the dial indicator is on 0 and the crankshaft turned 1 complete revolution in the direction of engine rotation. The maximum runout of the bore is 8/1000ths of an inch. If the reading is more than 8 thousandths, service the flywheel housing according to the vehicle manufacturer's recommendations. To check the end play of the crankshaft, place the tip of the dial indicator against the hub of the flywheel and the base of the indicator on the flywheel housing. Now, pull the flywheel away from the engine and check the reading against the engine manufacturer's specifications. Follow instructions to service the crankshaft if necessary. Next, examine the clutch that has been removed from the vehicle closely to determine the cause of failure. Examination at this point can provide a lot of useful information. The transmission mating surfaces and the clutch-related parts must also be inspected thoroughly before reinstallation. The splines on the input shaft are checked for burrs, damage, or wear that would prevent the clutch from sliding during operation. Replace the input shaft if it is worn. Check the fingers on the release yoke for uneven wear and verify that the shaft rotates freely throughout its entire travel. The shaft should not be restricted from side-to-side travel. There should not be any radial travel in the bore of the housing. Replace the shaft if there is any excessive travel. Of course, all dirt and grease must be removed from the mounting surface of the bell housing. You are now ready to install the Rockwell double-disc clutch. In order for the clutch to operate properly, it must be installed and adjusted properly. Proper installation of the 14-inch clutch begins with the replacement of the drive pins in the flywheel housing. This is accomplished with a hammer and drift after removing the set screws that fasten the drive pins in the flywheel housing. The new pin is inserted and a machinist square is used to make sure that the side of the drive pin is at a right angle to the top of the flywheel housing. Use a C-clamp to press the pin into the housing until the head touches the wall. Set screws are installed to fasten the drive pin to the flywheel housing. Now, temporarily position the center plate. The slots in the center plate must fit over the drive pins so that the plate moves easily. After installing and lubricating the pilot bearing, guide studs are installed in 2 of the upper mounting holes for the clutch cover to aid in installation. On 14-inch clutches with non-synchronized transmissions, anti-rattle clips are used. The clips are installed between the drive pins with the 2 half-round holes positioned toward the flywheel. Clutch discs should be inspected before installation to be sure that they are free of grease and oil. If worn or damaged, discs must be replaced. The discs are not interchangeable. To avoid the possibility of improper mounting, each disc has an identification. The words pressure plate side are stamped on one disc and flywheel side on the other. The front disc is installed, making sure the side stamped flywheel side is against the flywheel. Next, on 14-inch clutches, the center plate is installed so that the holes in the plate are over the drive pins on the flywheel. The spline alignment tool is then inserted into the rear disc, making sure the splines of the tool engage the splines of the hub. The rear disc is installed against the center plate with the pressure plate side properly oriented toward the clutch cover assembly. For 15.5-inch clutches, the rear disc is installed against the pressure plate of the clutch cover with the words pressure plate side against the pressure plate. Then install the center plate, making sure its tabs engage the slots in the clutch cover. The front drive disc is installed with the words flywheel side facing out. Positioned this way, the build-up assembly will be properly facing the flywheel when mounted. Spacers are shipped with the Rockwell clutch and are positioned between the release bearing assembly and the clutch cover. They should not be removed until after installation. The clutch cover assembly is guided very carefully over the spline alignment tool and onto the guide studs. The clutch cover and pressure plate assembly are pushed against the flywheel and the cap screws installed. After the cap screws have been installed and hand tightened, the guide studs are removed and replaced with cap screws. The cap screws are then tightened evenly and alternately to the torque specified by the manufacturer. This action will move the release bearing away from the cover, allowing the spacers to fall free. Once this task is completed, the alignment tool can be removed. The release bearing is free to rotate now, and it should be turned so that the grease fitting is toward the inspection hole in the clutch housing. Once done, the clutch should be lubricated. On non-synchronized transmissions, prior to installing the transmission, the clutch brake is positioned over the input shaft and against the housing, making sure not to get it greasy in the process. As the mechanic installs the transmission, he'll be aligning the input shaft with the pilot bearing in the flywheel. He'll make sure that the two fingers of the release yoke are installed between the release bearing assembly and the clutch cover. To make sure that the fingers of the release yoke clear the release bearing and are rotated over the pads, it may be necessary to turn the output yoke of the transmission so that the splines of the input shaft are aligned with the splines in the hubs of the discs. The installation of the transmission will be followed by the reconnection of the clutch linkage and the shift lever, and by hooking up the air lines and electrical connections. Before installing the drive shaft, check the operation of the clutch. With the clutch pedal pressed to the floor, the output shaft of the transmission should rotate freely. With the clutch pedal up, you should not be able to rotate the output shaft of the transmission. Let's review some of the key points of the installation. Use guide studs and the proper alignment tool or input shaft to align the clutch discs and support the clutch assembly during removal and installation. Inspect very closely those areas of the flywheel, transmission, and the clutch that might incur wear or damage. Check runout of the flywheel surfaces. Replace all worn, damaged, or uneven parts. Install new drive pins or anti-rattle clips if they were used in the original assembly. Install the new clutch in sequence. Front disc marked with flywheel side to the flywheel, then the center plate. Rear disc marked with pressure plate side toward the cover, then the pressure plate and cover assembly. On 14-inch clutches, make sure the center plate moves freely on the drive pins in the flywheel housing. Once installed, the clutch must be adjusted to assure correct operation and maximum service life. Two procedures are used to adjust the clutch system. The first is the clutch internal adjustment, which is followed by a linkage adjustment. The clutch internal adjustment is performed anytime the clutch is serviced and when the free travel of the clutch pedal is less than 1/2 inch. The internal adjustment is always completed before adjusting the linkage. The linkage adjustment is performed when any part of the linkage system is serviced. Before starting either of the adjustment procedures, make sure the complete system is in good condition and operating correctly. To do this, step on the clutch pedal and push it to the end of travel while someone observes the release lever. When the clutch pedal moves, the release lever must also move. Motion must not be lost between the clutch pedal and the release lever. These are the different sequences of the movement of the clutch pedal. From the beginning of the movement through the first 1.5 inches is called the free travel. Very little resistance should be felt here. From 1.5 inches to the end of travel, resistance is felt in the movement of the clutch pedal. On clutches used with non-synchronized transmissions, hard resistance must be felt 1 inch before the end of pedal travel, where the release bearing touches the clutch brake on the input shaft of the transmission. Make sure that the linkage is tight and moves freely during the operation of the vehicle. If the linkage is loose or damaged, the travel distance of the release bearing is affected. When you verify that the system is in good condition and all components are operating correctly, you're ready to begin the internal adjustment of the clutch. The clutch housing has an inspection hole which is covered during operation. By removing the cover, access is provided to the clutch for adjustment and lubrication. To begin the adjustment procedure, rotate the flywheel so that the lock plate is positioned at the inspection hole. Then remove the lock plate. For synchronized transmissions, check the distance between the release bearing and the clutch cover. Check the installation instructions for the specified dimension. For non-synchronized transmissions, the distance between the release bearing and the clutch brake is 1/2 inch. The adjusting ring must be rotated if these distances are not at the specified dimension. During the adjustment, the clutch pedal must be depressed to the bottom of the pedal travel and held. A tool is used to rotate the adjusting ring, which moves the release bearing to the specified dimension. The bearing will move 27 thousandths of an inch when the adjusting ring is moved 1 lug. An adjusting ring tool is available from either Kentmore tools or Owatonna tools. In place of the tool, a pry bar or large screwdriver can be used as a lever against the bosses on the adjusting ring. Regardless of the tool used, it's very important that the clutch be adjusted properly. After installing the lock plate and releasing the clutch pedal, there should be a clearance of 1/8 inch between the tips of the release forks and the pads on the release bearing assembly. If not, adjust the linkage. These are the parts of the clutch linkage adjustment: the pedal travel, the pedal height, and the free travel. The pedal travel and height adjustment must be performed before the free travel adjustment. There are 2 kinds of linkage systems, mechanical and hydraulic, and there are 2 types of mechanical linkage systems, cable and rod. In the rod type systems, 2 or more rods are used to transfer the motion of the clutch pedal to the release lever. The complete distance that the clutch pedal moves is called the total travel and is usually adjusted with bumper bolts inside the cab or with stop bolts and pads on the linkage. The pedal height is the distance the pedal is from the floor when the clutch is released. It is adjusted by jam nuts on a control rod, bumper bolts, or stop bolts and pads. See the recommended procedure of the vehicle manufacturer. Free travel is the distance the pedal is depressed until the release bearing starts to move. It should be approximately 1.5 inches, but may vary among truck manufacturers. If it's more, the clutch may not release. The clutch disc could then touch the flywheel. If less than 1/2 inch, the clutch will slip. In either case, premature wear, excessive heat, and early replacement of the disc will be the result. For non-synchronized transmissions with clutch brakes, adjust the external linkage so that the release bearing assembly touches the clutch brake on the input shaft when the clutch pedal is approximately 1 inch from the floor. For synchronized transmissions, the linkage is adjusted until the tips of the release fork are 1/8 inch from the pads on the release bearing assembly. For proper disengagement, the release bearing should move at least 1/2 inch when the clutch is fully depressed. The linkage is adjusted to the free travel specification, where it's connected to the release lever and to the clutch pedal. On rod type linkage, every rod is adjusted. This is accomplished with jam nuts, threaded rods, or with stop bolts. The manufacturer of the vehicle will have a recommended procedure. Proper clutch adjustment is the key to assuring that the Rockwell clutch will provide the performance you need and expect. Let's review. For synchronized transmissions, check the instruction sheet for the specified dimension between the release bearing and the cover. For non-synchronized transmissions, it's 1/2 inch between the release bearing and the clutch brake. Both clutches are adjusted properly if the clearance between the tips of the release fork and the pads on the release bearing is 1/8 of an inch. The release bearing must move at least 1/2 inch when the pedal is fully depressed. Clutch pedal free travel is approximately 1.5 inches. Proper installation, followed by proper adjustment, will allow the Rockwell double disc clutch to operate to the full reach of its design. And that means more dependable load carrying capability and a longer lasting drivetrain for independent and fleet haulers.